Let's solve few proving problems. Look at the first one. So if a is equal to, if y is equal to so much, then prove that this is equal to 0, correct? So first what we'll do, we'll take the value of y, which is a sin x plus b cos x. Alright, differentiate. First order derivative. Y dash is equal to a cos x minus b sin x. Right? Again differentiate, double derivative. Y double dash minus a sin x minus b cos x. Correct? Now, next thing, what do we have? Y value is given as a sin x plus b cos x. Correct? It's a given question. See what you are trying to prove. Y double dash plus y is equal to 0. Correct? So, y double dash plus y. This is going to be minus a sin x minus b cos x. This is y double dash plus a sin x plus b cos x. Cosine, sine, both of them cancels out. So what do you would get the final result? Therefore, y double dash plus y is equal to 0. Done. This is what we are trying to prove. Fair enough? Now let's do the second one. The second problem, this is quite an important one because in many of the exams and tests, they have asked this particular question. Alright? See, what we are trying to do is, if y is equal to sine inverse of x, then show that this is equal to 0. Right? See, if you look at this one, we have y dash and y double dash both, correct? So we have y double dash and this is y dash. We need to do both of them, correct? So first what we'll do, y dash. So y dash becomes 1 by root 1 minus x square. Now you can do y double dash directly, alright, or there is another easier way. That is, so this implies root 1 minus x square into y dash is equal to 1, correct? When you cross multiply, square on both the sides. When you square, you will get 1 minus x square into y dash whole square is equal to 1. Squaring on both the sides. Now differentiate. See, now if you differentiate, the LHS part derivative is going to become minus 2x into y dash whole square. Correct? Next, plus 1 minus x square into 2y dash into y double dash. This is equal to 0. Now, let me tell you what we have done. First, what we do, you differentiate this one. That's minus 2x because that's going to be 0 minus 2x, right? Then, keep the y dash whole square constant. So, y dash whole square constant. In the second part, keep the 1 minus x square as it is here, right? Then, what is the next part? You are going to differentiate this, right? What is the derivative of y square? 2y into y dash, right? Like if you have y square, what do? 2y into y dash. So what if you have y dash whole square? So you'll get 2y dash into derivative of y dash, which is y double dash. Isn't it? That's what we have done here. And this value is equal to 0. Now, y dash is common everywhere, correct? And also if you look at it, 2 is common everywhere. So take 2y dash common. You'll get minus x into y dash plus 1 minus x square to y double dash is equal to 0. So this 2y dash, if you take it to the other side, it's going to become 0. Correct? So what do you have? The remaining part, what do you have? So the remaining will write it here itself. So you have 1 minus x square, 1 minus x square, Ayo. 1 minus x square into d square y by dx square, that's y double dash, minus x into y dash is equal to 0. Don't you think that's what you're trying to prove here? That's all there is. So you cross multiply, square it, you will get the answer. Well and good. Fine. Let's do the next one. See the third one. Y is cos inverse x. Find d square y by dx square in terms of y alone. There should be no x term whatsoever. Fine. So what you have is y is cos inverse x. So y dash becomes minus 1 by root 1 minus x square. Fair enough. Cross multiply. So if you do that, you'll get root 1 minus x square into y dash is equal to minus 1. Correct? Square on both the sides. Alright, so if you square on both the sides, 1 minus x square into y dash whole square is equal to 1. Correct? Now differentiate, like you need the second order derivative, isn't it? Differentiate. So you will get minus 2x into y dash whole square plus 1 minus x square to y dash y double dash is equal to 0. Correct? Again, divide by 2y dash, or you can say 2y dash is common, you can take it common. So you will have x minus x into y dash plus 1 minus x square into y double dash is equal to 0. Now remember, what you need to do, you need to write everything in terms of y alone. There should be no x term whatsoever. But we have x term here, isn't it? So what we do, first thing what you can do is 1 minus x square into y double dash is equal to x into y dash. First point, correct? Now, y double dash x into y dash divided by 1 minus x square. Make sense? Next thing what you can do, see the y dash value. So if you look at this y dash, it's minus 1 by root of 1 minus x square. Correct? So we have to do some or the other calculation here to get the value. Fair enough? So let's do this one now. You have y double dash is xy dash by 1 minus x square, right? See, y dash is what? Minus 1 by root 1 minus x square, correct? Or you can say that root 1 minus x square is minus 1 by y dash. Now square on both the sides. If you square, 1 minus x square becomes 1 by y dash whole square, correct? Substitute that here. That means y double dash is x into y dash divided by 1 by y dash whole square. Or you can call this as x into y dash whole cube, correct? Right? We have one more, x. Now, to find the value of this one, what we do? So, you take y is equal to cos inverse of x. What is x value? Cos y, right? Substitute that here. That means in place of x, you substitute cos y. So final answer becomes y double dash is y dash whole cube into cos y. See, you're writing y double dash only in terms of y, not in terms of x. So this becomes the answer for the third question. Now let's do the fourth one. See the fourth one now. y is equal to so much, directly differentiate, get y dash. So y dash becomes minus 3 sine of log x divided by x plus 4 cos of log x divided by x. Isn't it? Now what we do, multiply both LHS and RHS by x. Understood? Or you can also say that x is the LCM of the RHS. Just cross multiply, you'll get it. Okay? The end result in both the cases, it's gonna be x into y dash will be minus 3 sine of log x 4 cos of log x. Fine? Differentiate again. So if you differentiate LHS, we have to apply the product rule, which will become y dash plus x into y double dash. Correct? This will be what? Minus 3 cos of log x divided by x minus 4 sine of log x divided by x. I hope this is clear because we are just using the chain rule. That's all. Nothing more, nothing less. So you have the cosine function first, differentiate sine. Then inside part you have log x, differentiate 1 by x. That's how you got it. Correct? Again, here what you do? You are going to multiply the entire equation by x. See, if you multiply, what you are going to get is x into y dash plus x square into y double dash minus of 3 cos log x plus 4 sine log x. Right? Look at the question. So if you look at the question, this is nothing but y. That means this is nothing but y. Correct? So what do you get? You get x square into y double dash plus x into y dash is minus y. Take the y on this side. You will get x square into y2 y double dash plus x into y1 plus y is equal to 0. See, this is what it is. All right, this is the answer for the fourth one. Let's do the next one now. See the fifth one. Y is so much and they're asking you to prove it, right? So let's first directly differentiate. All right, so when you differentiate, y dash will be a into m e power mx plus b into n e power nx. Correct? This is y dash. Now what we'll do, see, you can't do anything because there is no divided by or minus or nothing doing. Just keep it as it is. Differentiate now itself. Like again you differentiate. Do y double dash. So when you do y double dash, a m square e power mx plus b n square e power nx. Correct? Again, do you see anything common? No. Do you have anything divided by to cross multiply? No, nothing doing. Correct? Now, when you get y dash and y double dash, you substitute in this one and this one. All right, just substitute. So what do you get now? Y double dash, that is a m square e power mx plus b n square e power nx. Y double dash minus of m plus n into a m e power mx plus b n e power nx plus mn into y. You need to prove that this value is 0, isn't it? So let's do the normal multiplication and we'll figure it out. All right. First, what we'll do, we are going to take this one. All right. So let's take this one, multiply. So when you multiply m into this, which is a m square e power mx plus bmn into e to the power of nx plus amn e power mx plus bn square e power nx, correct? Remember, a very, very important point is we have a minus sign here. That means this is minus of the whole thing, isn't it? Look at the y double dash here. Y double dash is what? am square e power mx plus bn square e power nx, right? So when you have the minus and plus, don't you think this and this cancels, this and this cancels? Is it not? So we have the cancellation part. What remains? We are going to write it. So what remains is minus amn e power mx minus bmn e power nx. Correct? First part. Remember, we have not yet done the mn into y part, which we are going to do now. Alright? So, first this is what is remaining. The next one is what? Plus mn into y. Correct? That's basically we are doing mn into this particular term. Mn into y. See, when you do that, you'll get mn into a e power mx plus mn into b e power nx. Correct? So this and this cancels, this and this cancels. So what is the final result? This entire thing becomes 0. That is what we are trying to prove. Correct? Clear with this? So every time when you can't, cross multiply or do any of these things, just substitute and get the answer. Fair enough? Let's do the next one. See, now the next one, if you look at it, e power y into this, you need to show it, correct? First, what you do, you can take e power y is equal to 1 divided by x plus 1, correct? There is an easier way, taking log. So, log of e power y is log of 1 by x plus 1, correct? Which is going to become y. Log of e power y is y. Y is equal to minus log of x plus 1. Okay. Now what you can do, y plus log of x plus 1 is 0. Now do it, it's easier. Okay. Y dash plus 1 by x plus 1 is equal to 0, or y dash is equal to minus 1 by x plus 1. Correct? Again differentiate. Y double dash is equal to, so x plus 1 whole square, correct? X plus 1 whole square into, here it's gonna be 0 minus of, so what are you going to get here? This is going to become x plus, so it's going to be minus 1, correct? So what you are going to have, y double dash 1 by x plus 1 whole square. Now look at this one, d square y by dx square is dy by dx whole square. Don't you think so? Y double dash is equal to y dash whole square, because look at this, this is y double dash, this is y dash. Y double dash is y dash whole square, isn't it? So we got the answer for the sixth one. Alright, now let's do the last one. Let's solve the last one now. See here, first differentiate, normally differentiate. So you get y dash 2 tan inverse of x divided by 1 plus x square, correct? Cross multiply, you'll get x square plus 1 into y dash is equal to 2 tan inverse x. Again differentiate, double derivative. So if you do double derivative, 2x into y dash plus x square plus 1 into y double dash 2 divided by 1 plus x square. Alright, cross multiply. So if you cross multiply, x square plus 1 whole square into y double dash plus 2x into x square plus 1 into y dash is equal to 2. Isn't it what we are looking at? Correct? So this is going to give us the final answer. Clear? So these are the type of problems where we are looking at the proving type. So this is given, prove this one. This is given, show that this is equal to this. Fine. So these are the major type of problems what you have in the second order derivative or double differentiation. So in the next video, we'll look into the next type what you have in differentiation.